Okay, guys, welcome back. This time we're going to talk about the moon. Now, the moon is probably the largest thing you're going to look at when you go outside at night other than the sun. So what is it? When are you going to see it? What are the times? Things like that. If you have not gone ahead and printed off the information that I have labeled for you under the moon and the diagrams, I would like for you to go ahead and do that now before you go ahead and continue. So kind of turn me off here for just a minute. Make sure you have that on there and then come back. So let's go ahead and talk about the moon. They make them believe, according to the proverb, that glowworms are lanterns and the moon is made of green cheese. You didn't know it was made of green cheese, did you guys? Well, that was back in 1574. And since then, they've always wondered exactly what the moon is and what it's like and what was really up there. So we have gone there. We did make it in 1969. And when we start talking about the solar system, we'll kind of go through the Apollo program and exactly what it did and how we finally landed on the moon. But those footprints are still there. There's no atmosphere or anything else to go ahead and disturb those. So if we ever have any kind of permanent presence on the moon, which hopefully we will sometime, and probably not my lifetime, but hopefully in your lifetime, you'll be able to go up there and see those footprints. Okay, guys, who was the first person to step on the moon? Do you know? Probably know that, Neil Armstrong. Do you know who the second person was? I want you to ponder that and tell me that next time. So there's the moon. Can you see the face in the moon? See the eyes there, the nose, that nice little prominent crater right there at the bottom. Well, notice, guys, that we always see the same side of the moon. You never see the back side of the moon. Now, the moon and the sun look the same relative size, but it's a big one, guys, because a lot of people don't really understand that. The sun is much, much larger. They only look the same size because the moon's much closer than what we are to the sun. Okay. Also, guys, we go around the sun. The sun doesn't go around us. Now, you think that's a trivial question, but unfortunately, a lot of people in the general public out there don't really realize that we go around the sun and it's not the other way around. So, guys, you're taking an astronomy class. The Earth goes around the sun, not the sun going around us. And the moon goes around us. Okay? And so we know the moon's about 240,000 miles away versus about 93 million miles away for the sun. Now, if we look then at the backside, which we never have a chance to do until we're actually orbiting it, we find the backside looks much different than the front side. There's the front side. There's the backside. First thing you notice is you don't have a lot of the seas. And I put those in quotation marks, guys, because they're not seas that we associate with as in liquid water. They came from liquid molten material, think of lava, that went ahead and cooled and solidified. So you don't see a lot of those on the backside of the moon or the hidden side of the moon. What you do see is a lot of craters, and that's because it's facing away from us, and so it's not being protected because it's facing toward the Earth, and so you do get a lot more craters than on the backside than you do on the front side. When we go ahead and talk about the solar system, we'll come back and talk a little bit more about what is going on with the moon, things like that. What my purpose today, though, is to look at the phases of the moon and when you can see the moon in the sky, and then what happens during eclipses. So the moon takes about 28 and a half days to go through its phases. Now, remember I said we always see the same side of the moon. It's always facing the Earth. Well, that means that it takes the same amount of time to revolve around the Earth as it does to rotate on its axis. Now, revolving, remember, means I have one object going around another. Rotating simply means that I am rotating around a common axis. So because it takes the same amount of time to rotate once as it does to revolve once, then we always see the same side of the moon. Now I want you to go visit this site later on, not right now, guys, and look at what it's telling you about the phases of the moon as well as when those phases of the moon occur. There are 5 different phases that I want you to know. One of them is a new phase, crescent phase, quarter phase, gibbous phase, and full. And within the crescent, the quarter, and the gibbous, we'll actually have several of those depending on where we are within the cycle of the orbit of the moon. Now, the other 2 terms I want you to know is that waxing means you are increasing the visible surface of the moon, And waning means you are decreasing the visible surface of the moon. So that's going to help when we start trying to name these phases. So waxing, increasing the visible surface of the moon. Waning is decreasing the visible surface of the moon. Now you have this on Blackboard. Remember I had you go ahead and print this off? So we're going to use this, and you will need either a pen or a pencil or something like that to use as a horizon. The other thing that you need is you're going to have something like this, only it's going to be blank. It's just going to have nice circles in there, okay, with nothing filled in. You will also need that. So let's go back to this one. One of the things I want to do is go through and show you what the phases look like, when the phases are visible, how they appear in the sky, and then what time they rise, what time they're straight overhead, and what time they set. Now, if you just look at this diagram right here, and you've got one in front of you, look where noon is. Okay, so I've got the Earth, and the Earth is that big thing in blue right in the center. Okay, and we're going to assume that the Earth and the Sun are going to stay in the same relative position, so they're not going to change. Okay. And so we're going to look at what happens at the Moon in position 1, position 2, 3, 4, 5, 6, 7, and 8. Now notice, guys, that I have each one of those moons divided in half. And half of it I have drawn in yellow or colored in yellow, and half of it in black. Now, if you don't have a colored printer, it's probably just going to come out as kind of a milky white, maybe a little bit, as opposed to a yellow. But all that means is you've got one side that is always facing the sun and one side that's always away from the sun. Now, it doesn't really matter where in the orbit we're talking about or what we can see, we being the Earth. The reason that the moon is shining is because of reflected sunlight. The reason the Earth is shining is because of reflected sunlight. Okay? So I've got noon, which means if I'm on the Earth and I'm looking straight overhead at the sun, then I'm defining that as noon. If I'm on the Earth and I'm looking directly away from the sun, then I'm talking about midnight. And so you can also think of those 8 positions of the moon as a clock, a 24-hour clock, starting with noon and then coming all the way back around to noon. Now, so let's look at position number 1. Now, what I want you to do is I want you to take your pencil or your pen, decide one side is east and one side is west. I don't care which one you decide, but you just got to be consistent. Okay? So whichever side of your pen or pencil ever end that you're going to use as east, I want you to put that on position number 7. And whatever side you're going to decide is west, I want you to put that on position 3. Notice the direction that we are rotating. Okay? And you can see that with the little arrows that are on there. Okay, stop. Becky, remind yourself to go put arrows on that diagram. Okay. Yeah, because I don't have a little arrow on there. Okay, so now if I go back and I look, we're assuming that it's going to take 12 hours to go from horizon to horizon. So I'm going to rise in the east. I'm going to take 12 hours then to set in the west. And so that's why the other thing I wanted is your pen to have, or your pencil to have an eastern horizon end and a western horizon. The eastern horizon goes on number 7. The western horizon goes on number 3. So that means that position number 7 is 6 a.m., position number 3 is 6 p.m. You're straight overhead at noon because it's going to take 12 hours to go from horizon to horizon. Halfway through, I'm going to be straight overhead, which in this case is going to be 1 or noon. So now, if I'm on the Earth and I'm looking straight up at noon, notice that I'm not going to see anything for the moon. I'm going to see the sun. But the problem is the side of the moon that I would normally see is dark because the sun is hitting the other side. We call that a new moon, okay, in which case we don't see anything. Position number 1, I want you to completely cover it in because whatever you cover, whatever you color on that surface means that we are not seeing it. So position number 1, I want you to completely color in. Okay, so that's your blank one. Okay, so position number 1 is completely colored in. Now, let's go back. Now I'm going to go to position number 2. Okay, so guys, now I want you to take your horizon. I want you to rotate your horizon to 8 and 4. Okay, because we're looking at position number 2 straight overhead. Okay, I want you to rotate your horizon. So that your eastern horizon is at number 8, your western horizon is at number 4. So position number 2 is going to rise on the eastern horizon, be straight overhead at position number 2, and going to set at position number 4. Okay, guys, if I know that position number 1 is noon, and I know position number 3 is 6 p.m., then what time is number 2 straight overhead? Well, think. What's 3 hours from noon and 3 hours before 6 p.m.? So it's got to be 3 p.m. So that means position number 2 is straight overhead at 3 p.m. Now the next question is, what does position number 2 look like? Well, if I think about where that circle is, it goes through position number 2. Notice if I'm looking at position number 2, I basically see a moon that is dark with just a little bit of a sliver on the right side. So think about the way that you're looking at that, guys. Okay, the right side is going to be lit, and it's only going to be a small little sliver. Okay, most of the rest of the surface is going to go ahead and be dark. So that's what I want you to do on your second position. Go ahead and make a small little kind of a crescent, and then about 3/4 of the moon then is dark. Please make note that it is the right side of the moon that is lit. Okay, so you've got a nice thin crescent. 3/4 of that is dark. Now, let's go back and look at that same picture again. Rotate your horizon. So now you're at position number 1 for your eastern horizon, position number 5 for your western horizon. We are now looking at position number 3 straight overhead at 6 p.m. Well, if I look at that, I think you can see that position number 3 has exactly half the moon that is lit and half the moon that is dark. Because remember, guys, we're only looking at the part that we can see. And if it helps, take another ruler or pencil or something and just make a tangent line to that circle, and so you can see that that's what we're seeing. Well, if I then draw that out, that means half of my moon is dark on the left side, half of it is right, and it's lit. So that's what position number 3 looks like. Okay. Now, guys, is this waxing or waning? Remember, waxing is when you're increasing the visible surface of the moon. Waning is when I am decreasing the visible surface. Well, look how our picture has changed from 1 to 2 to 3. 1, I had no visible surface at all. Number 2, I have a small crescent. Number 3, I'm going to have a quarter. We're going to find out that it's going to be the first quarter. Okay, so now let's look back at position number 4. Okay, rotate your horizon. If we're looking at position number 4, then that means our eastern horizon has to be at position number 2. Our western horizon has to be at position number 6. We're looking at position number 4. If you need to, draw that tangent line or use a ruler and put it across there so it's tangent to the circle so that you can see the part of the moon that we're seeing. And I think you can see that you're now seeing more of the lit surface than what you had before. Well, that's our gibbous phase, and it's going to look something like position number 4. Now, I want you to compare position number 2 and position number 4. Notice that on position number 4, I just have a dark crescent, whereas position number 2, I have a light crescent. Okay? On position number 4, I have more of the lit surface that is forming basically the inside of that crescent, and same way with the dark part on position number 2. I am still increasing the visible surface of the moon that I'm seeing. And that's one of the ways you can always tell whether you're talking about a waning or a waxing moon. Waxing always has the visible side of the moon that is lit to the right. Okay? Whereas the dark side is always to the left. Didn't they make a song out of that, the dark side of the moon? I don't remember who did that. Pink Floyd. Oh, yes, because he also did the really cool shirt with a spectrum on it. Yes. Now, let's go back to back to our picture. Now, let's look at position number 5. Now, remember, guys, we're looking at midnight now, so we're looking completely away from the sun. Okay, so that means our horizon has switched as well. Our eastern horizon, remember, take your pen or your pencil, move it so that your eastern horizon is position number 5. Your western horizon is at position number 7. So I rise in the east, I set in the west. Looking at position number 5, I'm looking straight up. I'm seeing a full moon, guys. So position number 5, no coloring at all on that space. It's a full moon. And so I have a maximum amount of visible surface that I'm going to see. Now, if I go back and look at this, you think that we're talking about a full moon, and remember, we're looking at in general in terms of when these times are rising and setting. Notice that a full moon, position number 5, rises at 6 p.m., sets at 6 a.m. Well, in a nice, perfect world, guys, the sun is going to set at 6 p.m. and it's going to rise at 6 a.m. You've got a full moon, which is always, to allow us to see the full surface, at least the visible surface that we see, it's always going to be directly opposite. So a full moon is going to rise when the sun sets, and it's going to set when the sun rises. Let's go back and look at the new moon. That's position number 1. It's going to follow the sun, whereas the full moon is just the opposite. So you can always tell when you look at that full moon exactly where the sun is. And again, you have your horizon has been rotated, so you can see that it rises at 6 p.m. It goes ahead and sets at 6 a.m. Now, let's start then looking at what happens when we look at position number 6. Rotate your horizon, guys, so that your eastern horizon is at position number 4. Your western horizon is at position number 8. Now, you may need to rotate your paper, guys, because I want you to then to still be able to look at the moon so that you can tell which side is lit, whether it's the right or left. And so you may need to completely rotate your entire paper so that you're looking at it and you can tell which one's right or left. Now, when I look at position number 6, we now have that opposite of position number 2. I'm starting to decrease the visible surface of the moon. Notice that the visible surface is still on, in this case, the left, which is why I had you rotate that if you needed to. We've still got the gibbous phase. So you can see the inside of that crescent that's dark, and the rest of it is going to be lit. Now, I go back to position number 7. Rotate your horizon, guys, to 5 and 1. Rises at midnight, straight overhead at 6 a.m., sets at noon. Okay, and if you can see there, it's just exactly the opposite of what you were looking at with position number 3. And notice that the left side is lit, the right side is dark. Okay, that's going to be 3/4 of the way through our orbit, so we're actually going to call that third quarter, but we'll put names on here in just a minute. And then if I go back and I look at position number 8, rotate your horizon. Eastern horizon is at 6, western horizon is at 2. I'm back down to the opposite of what I saw in position number 2, that really thin crescent. And most of the moon is going to be dark because I'm heading into a new moon. So look at position number 8. Now, if I look at this picture, I can see that 1 and 5 are completely opposite. Okay, 2 and 6 are again completely opposite in terms of what's lit and what's dark. 3 and 7 are opposite relative to what's lit and what's dark. And 4 and 8 are opposite relative to what's lit and what's not. And then 2 and 4 are opposite relative to the, looking at the curvature there, same way with 6 and 8. And then, of course, 3 and 7 are the opposite as well. So what does all that mean? Okay, these are the phases. So let's talk about the naming of the phases. Position number 1 is going to be called a new moon because you can't see it. Position number 5 is called a full moon. So guys, on the sheet that you have that you've been coloring in, you've got lines down there. Just go ahead and put the names in there. Position number 1 is a full moon. Position number 1 is a new moon. Position number 5 is a full moon. Okay, if I start my orbit at 1 and finish back at 1, that means I'm 1/4 of the way through at position number 3. So we call position number 3 first quarter. Okay. That means position number 7 is third quarter. So I have new, first quarter, full, which is basically seeing half the surface of the moon, or the entire part of the moon that's visible to us, Then 7 is 3/4 of my way through my orbit. So that's why it's 3/4. And then I go back between 1 and 3. I've got a crescent. So number 2 is a crescent. Number 8 is a crescent. Number 4 is a gibbous. Number 6 is a gibbous. But which gibbuses are they? Okay, remember, waxing means I'm increasing. So number 2 is a waxing crescent. 4 is a waxing gibbous. 6 is a waning gibbous because I'm decreasing the visible surface. And number 8 is a waning crescent. Now, notice that my 2 crescents, my waxing crescent always is lit on the right side. My waning crescent is always lit on the left side. And that's the same way through the difference between my waxing and my waning. So you can always tell if one of them is waxing, because waxing is always going to be lit on the right side. Waning is always going to be lit on the left side. Now, you're interested, yes, you are interested in knowing when these things rise, when they're straight overhead and when they set. Because a lot of people think the only time you can ever see the moon is at night. And that's not true. If you know where to look, unless the sun completely drowns it out, you can go ahead and see it during the day. You have to look, but you can certainly see it during the day. So now remember, one of the reasons that I had you use the horizon, your pen or pencil, was so we could determine where it rises, when it's straight overhead, and when it sets. So these are my waxing phases. I have new, a waxing crescent, a first quarter, and a waxing gibbous. Okay, let's put where they're straight overhead to start with. I know that a new moon is straight overhead at noon. Go back and look at your pen. Put 6 hours between horizon to horizon, and that's noon. A crescent is straight overhead at 3 p.m. First quarter is straight overhead at 6 p.m. A gibbous, again a waxing gibbous, is straight overhead at 9 p.m. So let's go back and look at that picture. Okay, remember you're looking straight on at noon, and when you see a new moon straight overhead. Then you see position number 2, which is a waxing crescent straight overhead at 3 p.m. You see first quarter straight overhead at 6 p.m. You see a waxing gibbous straight overhead at 9 p.m. And you see at midnight a full moon straight overhead. Okay, so now let's rise and let's set. You always rise 6 hours early. You always set 6 hours later. So for a new moon, 6 hours earlier than noon is 6 a.m. And then you set at 6 p.m. Notice, guys, think about when the moon rises. Think about when the sun rises. Sun rises around 6 o'clock in the morning, sets around 6 o'clock in the evening. In a nice general world, guys, not specific, because you always have your own same time frames. But in general, rises in the morning around 6, sets around 6 p.m. So a new moon rises with the sun and sets with the sun. Crescent moon, straight overhead 3 p.m., so that has to rise 6 hours earlier, which is 9 a.m., and it sets at 9 p.m. First quarter, straight overhead at 6 p.m., it rises at noon, sets at midnight. The waxing gibbous, straight overhead at 9 p.m., so it rises at 3 p.m., sets at 3 a.m. Well, I think you can kind of see the patterns, guys. Everything is really offset by 3 hours. Noon, 3 p.m., 6 p.m., 9 p.m. Okay, rising at 6 a.m., then 9 a.m., noon, 3 p.m. So everything follows in rotation of 3 hours. Okay, so now same thing if I do the waning phases. We've already done the waxing, the waning work exactly the same way. A full moon rises 6 p.m., straight overhead at midnight, sets at 6 a.m. The waning gibbous rises at 9 p.m., sets at 3 a.m. Straight overhead at 3 a.m. and sets at then 9 a.m. Third quarter rises at midnight, straight overhead at 6 a.m., sets at noon. And then that waning crescent rises at 3 a.m. in the morning, straight overhead at 9 a.m., which means if you go out, you can see that crescent phase in the early morning, and then it's going to set at 3 p.m. You put both of these charts together, guys, again, they're offset by 3 hours going from rising overhead and setting. And if you go back and just look at that chart, it makes a lot of sense knowing exactly when it's rising, it's straight overhead, and it's setting. Now you're looking at a picture of the moon throughout its entire period for a month, 28 and a half days. You can see that it does change and wobble a little bit on its axis, sometimes a little bit closer to us, a little bit further away, depending on where it is in its orbit. Can you pick out where the phases are? Start with your new, and go to your full, and go back. Now, we also have eclipses. We have two basic types of eclipses, a lunar eclipse and a solar eclipse. Lunar eclipse means that the moon is being covered. Solar eclipse means the sun is being covered. But the question is, what's covering what? Remember, guys, we've talked about how the sun and the moon are the same relative size. It's just that one of them is much, much closer than the other one. So they both seem to have the same angular diameter. They both cover about an average of a half a degree in space. And again, that varies somewhat, but basically a half a degree. Now, we do not see eclipses every month because everything's not quite lined up. So basically, guys, you've got the sun, you've got the moon, and you've got the earth. And sometimes the moon is between the earth and the sun, sometimes it's on the other side. Okay? And so when they're all lined up in a nice straight line, all at that same orientation, that same angle, then we tend to go ahead and have eclipses. Remember, here's the moon again. A solar eclipse is going to occur when the moon moves between the earth and the sun. Okay, so you got the sun, you got the moon, and you got the earth. And remember that the earth and the sun are staying, at least for our purposes right now, in the same relative position. So I've got the sun, the moon coming around, and if everything's lined up correctly, what's going to happen is the moon is going to move in for that new position, remember, because that's where it's between the earth and the sun. And remember, it's out in space. Okay, the sun's shining on it, so it's going to cast a shadow of the moon. Well, what happens is that shadow then hits the surface of the earth. And that shadow moves across the surface of the earth. And when it does that, that's when we have a solar eclipse. So the sun is being blocked by the moon. So solar eclipse occurs when the moon moves between the earth and the sun, and we see the moon's shadow moving across the surface of the earth. Okay, so here's your diagram. You can see that there's the sun. There's the moon. You can see that shadow of the moon that I've got. And there's the earth. And that tip of that shadow just reaches the earth, and that's what we see moving across the surface of the earth, is the tip of the shadow. And that's why when we're talking about a solar eclipses generally have a very small audience because there's a very small area that actually moves across the surface of the earth. Because think about it, guys, most of the surface of the earth is an ocean, 75% of it. So most of the time those eclipses occur over the ocean and not over land. So we have a very small number of people seeing it because we have that very small pathway as we go. Now, if you were lucky enough to see a solar eclipse, number one, don't look up at the sun. Okay? Even though the sun doesn't appear to be there, you've still got a lot of energy in there. Okay? What you can do is, this is taken through a tree. You can see the tree there. It's the shadow of the tree. And I think you can see that there's lots and lots and lots and lots of little solar eclipses there. You can see the eclipse of the sun, and that's a shadow that's being cast then by the sun through that tree. So you can see it that way. And there's also a variety of other ways that you can look at a solar eclipse. The one thing you don't want to do is just look up with your naked eye. Now there is the shadow of the moon on the surface of the earth. Just like other things here on the earth have shadows cast by the sun, the moon is just out there in space, and so it has a shadow cast by that sun as well. And that's then what moves across the surface of the earth. There's a little bit more of it elongated as you see it. And again, it doesn't cover a really big area. We're going to find out with the lunar eclipses, they are seen by a much, much, much wider audience. You don't have to worry about being right underneath it. And that's really what you're looking at when you're looking at a solar eclipse, is you have to be right underneath that shadow to be able to see that eclipse. You see that shadow moving across? Well, that's the shadow of the moon as it's moving across the earth. you happen to be lucky enough to actually be under one, definitely go out and look at it. Now, these are just pictures of solar eclipses. Sometimes you get what's called an annular, where you have actually a ring of light. It didn't quite line up, and so you're going to get kind of a ring of light around there. So the moon didn't completely block the sun out. You're getting kind of like that last light of the moon of the sun that you see as the moon is blocking it out. It's called the diamond ring effect. Now, one of the cool things about it during a solar eclipse is because that moon is right in front of the sun, you can see any kind of phases or any kind of prominences, things like that are on the surface of the sun. The other thing is when you have them under a full solar eclipse, you then can go ahead and see the outer atmosphere of the sun. You can see the corona of the atmosphere of the sun. So this is a picture of the sun as it's going into that eclipse. You just look up and you slowly will see the sun going away. It's being covered by the moon. And here's a nice picture of the atmosphere of the sun, the corona. So it's a really good time to go ahead and be able to study what the corona of the sun is doing. Now, lunar eclipse, on the other hand, occurs when the moon moves into the Earth's shadow. So now let's reverse our positions. Think about what's happening. You've got the sun, you got the Earth. Remember, those are going to stay where they are. Now, look where the moon has moved to. We're talking about moving to the position number 5, which is when we had a full moon. So you got the sun, you got the Earth, and you've got the moon. And notice I've got the shadow of the Earth drawn, and so the moon then is moving through the shadow of the Earth. And therefore it's being put in dark. So you're basically seeing the moon go away. Now, this is a picture of what happens as that moon is moving into the Earth's shadow. And so you can see this moon slowly going away, but then all of a sudden you see it in red light. Well, a lot of times during a full lunar eclipse, what happens is you're going to get light that's being bent then around the Earth, and it's going to go ahead and show up the moon, and that's why you get that really red color. And that's going fully through the shadow of the Earth. And sometimes they won't completely go fully through the shadow, and you'll just have a partial lunar eclipse, so it'll be a little bit above or a little bit below, but if it goes right through and it completely blocks it out, then a lot of times, not always, but a lot of times you'll get that scattered light then that goes ahead and shows up and will illuminate the moon itself. It's a really cool thing to be able to see. So again, if you ever have a chance to go see a lunar eclipse, you don't really need anything special. You just go out there and look. And generally you also see them for a much longer period of time. Whereas a solar eclipse lasts just minutes, lunar eclipses may last for an hour or so. It's just moving into that eclipse. Just another series that kind of shows you as that moon is going into the eclipse and then what happens during the time that you have the total part of the eclipse. Okay, I really like this picture of the Stonehenge. Looking up there and seeing the moon as it going into an eclipse. Hasn't quite got there, but it's almost gone. Sometimes if you don't realize that you got an eclipse going on and the moon is coming up, you're looking going, wait a minute, I'm missing half the moon. Well, you are, because it's moved into the Earth's shadow. But I thought that was a cool picture, kind of halfway up into the eclipse already. Okay, guys, so that took us into lunar and solar eclipses, looking at the phases of the moon and what's going on from there. So next one we need to talk briefly about properties of light, and that will take care of then this unit. And then we will head on into talking about the solar system, what's going on there. So guys, talk to you later. Bye.